Before proceeding forward, let me tell you first of all what is direct current and alternating current. After this we will be able to find out what is actually the generator on work, like the working of generator we can define. So what is direct current and alternating current? First of all, these are the types of current, and here for the basic example I can tell you that direct current is we are going to use in batteries. Okay, so you know that the small cell and the battery which is having one positive terminal and negative terminal. So this is a direct current. It is going to haul through. It is not going to change its phase. Okay, phase will remain same. Phase will remain same. But in case of alternate current, okay, alternate current AC, we are calling it as AC. It is the type of current that is used in your houses. Like in power socket, what kind of current we are getting? We are getting alternate current, okay, in which phase is not same. It is going to change again and again within a second, within a minute parts of seconds it is going to change. Okay, that is why we are not able to distinguish whether it is going to change its phase or not. Even for a minute second, a fraction of second, it is going to be zero also. Okay, for a part of second, because when it is changing from any, like from positive to negative, it is moving. So in between what we will get? We will get zero. Now if it is getting from negative to positive, now in between again we are getting zero. So for a fraction of second we are having zero current also. But this is alternate current, and this was given by Tesla. Yeah, scientist Tesla, Nikola Tesla was the one of the famous scientists, and he has given us the biggest achievement of his life, and that is why we are able to do a lot of things right now. Because if this was not happen, then with the help of direct current only, we are not able to switch on this television, this monitor, this keyboard, anything, because these are the soft engines we can say. Okay, like in big machines, big type of mechanical things, we can use direct current because these are not going to change its phase. And this is absolutely a lot of current when you are fixing a current at one position, like this one. So it is going to be at the same position for the whole long. Like I have drawn here a graph. It is x-axis, y-axis. Once it is at this particular point that the current is flowing here for 5 ampere, so it will be 5 ampere for whole through the time. But in case of AC current, it is going to be changed simultaneously, and that is we need. We just don't need that continuously for every fraction of the second we are getting that current. But what we need, just for a while we can get this kind of current, then again reduce to zero, then again get high, and again get to reduce to zero and negative part. So this again will help us to sustain, to maintain the device at its original thing. Like that in Diwali time you are having this kind of series, okay, in which we use different light colors like this. Okay, so you have seen that these sometimes we bought such kind of series जिनको हम लड़ी भी बोलते हैं हिंदी में ना, जो डेकोरेशन के काम आती है. So ये क्या करते हैं? ब्लिंक करते हैं. Blink, like for this in the same manner, because this is more than a fraction जो 1/16 part होता है सेकंड का, उससे थोड़ा ज्यादा टाइम के लिए हो रहा है. दैट इज व्हाई वी आर एबल टू सी इट. बट अगर ये इससे भी रिड्यूस्ड पार्ट है, इससे भी कम पार्ट में अगर ये चीज चेंज हो रही होती तो हमें ये नजर नहीं आता. Okay, I think you got my point, that why we are able to see them blinking like this, because the time limit for 1, 2 changing in the phase is more second, more fraction part of second compared to the 1/16, and we are just able to see any kind of thing that is going to be changed when it is going to change in this fraction part only. Okay, if something is less than that, then we are not able to see that. That is why we are not able to see even some kind of series in Diwali time are such a thing like कि जो blink नहीं करती हैं. Okay, जैसे golden color की lights ले आते हैं हम, वो blink नहीं करती हैं, simply golden ही रहती है. But it doesn't mean कि वो blink कर ही नहीं रही है. They are blinking, they are getting AC current, that is alternate current, that is the phase at the point is going to change. But the thing is, it is so fast that our eyes cannot detect it. So this is what direct and alternate current, and here is the differentiation list. What is direct current? It is denoted by DC and alternate current is denoted by AC. Okay, so DC current, AC current, we can call it like this also. Now, in this direct current, you can see current flows, that is flowing. That means electrons are actually moving from one place to another inside through the wire. Okay, so they are moving. So transferring of electrons is done. Okay, like this is a complete circle, let's suppose, and it is connected to the battery. Fine. So now in this whole circuit, what is happening? The electrons are passing by like here, 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 and back to again the routine part. But in this case, what is happening in alternate current, electrons are not actually moving from one point to the circuit and coming back to the circuit. That is not going to happen in case of AC. What they are doing, they are just vibrating at their own position, like from here to here, here. Because here Tesla had thought about it, that what we need to bring the current, we just need to bring to move the electrons. That is the only need that sustain, that produce. That in the earlier part in electricity chapter we have seen that what we need to produce a current, we just need the motion of electrons. If we have done this motion of electrons, then we can say that current is here. Okay, now why we are moving these electrons from hole to the circuit? Why not we just move it from its own mean position and vibrate it like this? Okay, then also it is moving, it is not stationary right now, but at its own position. And that is again, this I can show you like this. If we are taking this part is the positive part and this part as the negative part, so now here we can say that once the phase of the current is positive, and when it is moving from positive phase to the negative phase, so we can say here that it is moving from positive to negative. So once it will be zero also. That is what the same thing I am going to tell you here. I was going to tell you here. Okay, from positive, zero, negative. So here we are suggesting that for a meanwhile, it is going to be zero again. Okay, so but what is we need here? We need the polarity, that we are having different polarity, again positive and negative, that again we are having in the same case in case of direct current. We are having that in the case of alternate current also. Very nice. Okay, but here with the polarity we are having, we don't have to put this electron go through whole of the circuit and come back to the original point. That we are not going to do. We just shake it at the mean position of its own, and here it is going to vibrate and producing the current. Now positive and negative polarity is fixed in case of direct current. That is the third point. Yeah, that is true, that I have told you that positive and negative is at the fixed position. In this alternate current case, what we are having, polarity is not fixed. Yes, because electron is phasing, it's vibrating on the phase of positive to negative and then again positive to negative. So we cannot judge if the polarity is same. So for that we can say that here in case of this, if once it is positive, it is negative. So we can say that current is moving from positive to negative like this. So this could be a case of that. We can say it is a positive polarity. We are supposing that this is the positive direction. So one, it is positive. So the opposite of it will be negative. If this is positive, this is negative. So now we can say this is negative polarity. But in case of direct current, we always use batteries. So here we will have only positive and only negative thing. One thing only. So if I ask you students, which is more dangerous? Like one of your students, let me guess the thing that one of you is putting your hand in the direct current and one is in the alternate current. Now, who will suffer more? Okay, now see here, as I have told you, the graph for this direct current will be like this, that it is not going to be zero at a single point. But in case here, what is the kind of graph that we are drafting? It is like this, alternate current. That means it is changing its phase. It is one time is positive and one time is negative, and for a while it is going to be zero also. So at the point of zero, here, we are having a chance to protect ourselves. Here, if a person who is getting his hand by chance into the case of it is touching something that is electrified right now and it is with the alternate current, then he or she will have a chance to reduce his hand, to move backward his hand. Why? Because at a fraction of second, we are having a chance that it is going to be zero. And one more thing. Students may confuse themselves with the thing that battery is very safe and this alternate current, as you know, that sockets are giving us more electricity. So fortunately we suggest that we are having more current in case of alternate current, but not like this, because battery is just for small use right now. We are having, if we can find that the frequency level of, if we are keeping the frequency level of this and frequency level of this alternate current both as same, because in case of battery we are keeping the frequency level very low, okay, and voltage is also very low. In case here alternate current, what voltage we are receiving at home? We are receiving 220 volt, okay, that is too high. And in case of battery, what voltage we are taking? We are just taking 3 or somehow 1.5 volt battery. Okay, so see the difference, 1 and 220, that is a large difference. So now if you are taking the battery of 220 volt again and both the things are same now you are facing the thing that here and here, in both the cases, which is going to be more hazardous. So definitely this will be the direct current, because here we are not even getting a single chance to get our hands back. Okay, so this was the thing. Okay, more difference on the direct and alternate current are as follows. Here we are having some more difference in between direct and alternate current in case of frequency. Let us turn it, defining it according to the frequency. So you know that direct current is not changing at all, because the graph for the direct current we have seen it like this, and in case of alternate current it is going to be like this. Okay, like this. It is going to change its phase, so we can draw it like this. So phase changing. So frequency is happening when the waves are here. In case of this, we are not having any kind of waves. In case of this, we are having waves. So how many waves are got transferred in 1 second? That is what the frequency is. But here in case of direct current, we are not having any kind of waves. So we can say that frequency is 0 in direct current. But in alternate current, frequency of this depends on the country. Yes. So what is frequency here? Actually, what is happening, students, that the generator, the thing that is making, that is producing the current in powerhouses. So what is happening here? The rotation of the generator, that is depend upon the force that we are providing, and that force again is depend upon the environment condition, like all the kind of force that we are required to produce the electricity, all are natural force, and that may be different ways. It may be solar energy, it may be nuclear energy, it may be atomic energy, it may be hydropower plants, any source. So it depends that country how they are producing it and how much rate they are providing to their citizens. Okay, so according to force provided here, this generator will rotate like this turbine will rotate, and accordingly the rotation, the number of rotation will signify the number of waves that is going to be produced, and in 1 second the number of waves that is going to be produced is going to define the number of frequency. So here in India, in case of India, what we are having 50 hertz. Okay, that means this is going to produce 50 rounds in a second. Okay, now current, in case of current, it is again a very specific thing that in direct current we are having a constant magnitude like this. So once it will be a 5 ampere, then it will be a 5 ampere for whole long thing. Okay, but here the current is going to be vary because phase is changing from positive to negative. Once again it is going to be 0 for a while. Fine. Now uses. So direct current is used in television. It is one of the example in lots of other things that we can use the direct currents, but alternate current is used to transmit current over long distances. Mainly the use of it is this, because in earlier time that was the problem. When earlier time we have just defined what is current, and in that case we have discovered direct current only. Okay, later on Nikola Tesla has discovered alternate current, and what he has observed that it is going to be long distance generators can cover. How? Because I have told you that in case of this, only electron will shake, only it will vibrate on its own position. So it is vibrating, transferring, vibrating, transferring, vibrating, transferring. So none of the electrons is moving from its original place to the another place and coming back. So no more energy dissipation is required. Okay, this is why it can go through a longer distance, and even from the power houses where the generation of the electricity is going to happen, from there to the sub houses, to the residential areas or to some other commercial areas, we are all distributing the electricity energy.